Here is our remote weather station. To give you an overview of the hardware, we have our weather vane on top, which is attached to this rod, and then there's also the encoder. Those are both rigidly attached. And then rotating freely around the rod, we have the wind speed sensor. Then we have our Hall effect sensor and the LEDs mounted down there, as well as the photoresistors. And over here, we have all our circuits, and of course the Raspberry Pi. To test it out, we're just going to use a room fan. You can see that the weather vane is pointing in the direction of the fan, and the wind speed sensor is rotating freely around the rod. If we move the fan, the weather vane will again point towards the fan, and the wind speed sensor will keep spinning. So the first thing I want to talk about is the LEDs that will measure the encoder position. The photoresistors are beneath the encoder. You can see the LEDs just lit up right there for half a second each. And that's just to save power, so they're not powered on when we're not reading. And then the Hall effect sensor is mounted up close to the rotating wind speed arms, and you can see the magnet go around right there. For the sake of demonstrating the error messages, I set the threshold temperature to, if it's greater than 20, that's an error. My room temperature right now is about 25 degrees Celsius, so it's sending me emails. And I diagnosed that it's the temperature that went out of bounds, and it tells the temperature so that you know what went wrong.
So here is a depiction of our HTML page, and just to elaborate how, I guess, interconnected it is. So the weather station's on South Campus, whereas I'm at the University View. So this is just showing how they're constantly updating. And so we have Test Studio in the background, nice little title, and then we also have a YouTube clip. And so we also noticed for updating the compass, because we want to show that as like a good way to show the wind direction changing. We noticed that unlike the ThingSpeak plots, which have a built-in dynamic equals true part of the HTML code, that same part does not apply to MATLAB analysis or MATLAB figures. So in order to do that, I included a meta refresh portion in the HTML code that refreshes the entire web page approximately every 30 seconds. It's every 30 seconds because it might be distracting to have it refresh every 16 seconds. But to get every 16 seconds, we showed here in the ThingSpeak plot, we showed every degree, so we do have that capability. And everything else looks to be running smoothly. Thank you.
Our 3D printed design is very elegant. Everything fits together well, and I think it looks cool, and it's very compact. The biggest challenge was getting the wind direction sensor to work correctly. It started out as spinning at the same rotational velocity as the wind speed sensors, so we had to loosen it on the axis, and then once we did that, it was just not quite spinning, so we increased the surface area of it by adding these paper turtles.